Here's verifying identities part 3. Here's our equation. We want to show that this equation does in fact equal each other. So we're going to use our identities. So we're going to work with the more difficult side, so we're going to work with the left-hand side. We want to get it to look like the right-hand side. So we're going to work with this piece. And we want it to finish up being negative tangent squared of x. So have your gold sheet out. All right. So I just rewrote the problem here. And I notice I have two identities. Both of them are Pythagorean identities. So on your gold sheet, look at your gold sheet and see if you can find them. Tangent squared of x plus 1. Do you see it? And do you see cosine squared of x minus 1? So one of the identities here, the tangent squared of x plus 1, is going to be replaced with secant squared of x. Now this one is a little bit harder to see. It's not exactly on your gold sheet, but you can change it. The sine squared of x plus the cosine squared of x equals 1. It doesn't look like that quite yet. So what we're going to do is we're going to solve this for the sine squared of x. So I'm going to subtract 1 minus the cosine squared of x. Well, that doesn't exactly look like it yet because I have a positive and then a minus. So can I do this instead? Take out a negative sign and then I get a negative 1 and a positive cosine squared of x? Sure. So I get negative sine squared of x equals cosine squared of x minus 1. Here is now my parentheses, so I can replace it with negative sine squared of x. All right, so we found this one, secant squared of x. If you want me to write it down, I can here. The tangent squared of x plus 1 equals secant squared of x. So here it is. So I can replace it right there. So there's my secant squared of x. And then my second parentheses can be replaced with negative sine squared of x. So I use my Pythagorean identities. Now I'm going to go ahead and use the Pythagorean or the reciprocal identity. I'm trying to convert this maybe to all sines and cosines. So the reciprocal identity says this. The secant of x equals 1 over the cosine of x. If I change this to a squared and a squared, I can replace this secant squared of x with 1 minus cosine squared of x. So there's your reciprocal identity. Now I can combine those two fractions together into 1. And the last step is noticing that we have a quotient identity. The quotient identity says this. The tangent of x equals the sine of x over the cosine of x. But I have squareds, so I can just increase this by a power of a squared, and a squared. So I have this, so I replace it with tangent squared of x. But I do still have this negative 1, so I have to pull the negative 1. All right, so there's negative 2 tangent squared of x. Let's come back up here. Is that what we wanted? Yep, negative tangent squared of x.